we'll be having a look at ventilators. Ventilators are designed to aid the patients who cannot breathe effectively or are unable to breathe by themselves. This life-saving equipment consists of a pump or blower that can transfer breathable air in and remove carbon dioxide out of the lungs. Depending on the way it delivers the breathable air into patients' lungs, a ventilator can be divided into two types, an invasive and a non-invasive. The non-invasive ventilator delivers air into the patient's lungs through a face mask that covers the patient's nose and mouth. An invasive type delivers air to the patient's lungs by an endotracheal tube that goes through the patient's nose or mouth into their windpipe. Modern ventilators are usually computerized equipment consisting of a blower, several sensors, and valves, as we'll see in the upcoming examples. The blower pushes air from the gas source, which can just be a mix of oxygen or a mix of oxygen and other elements, through the inspiratory valve and multiple sensors and eventually into the patient's lungs. At the same time, the MCU monitors the readings from the sensors and controls the blower speed or valve opening to achieve the desired pressure, flow rate, and oxygen levels. So we'll start off with the intensive care ventilator. This is the most large ventilator and features a wide range of flow rates and pressure settings and is often bulkier than other types. These ventilators, as we know, require a physical connection with the patients, hence need to meet the BF applied part standard. As the device is usually capable of higher flow rate and pressure, a more powerful medical grade AC/DC converter from 200 to 300 watts is required to be the main power source. In this example, the 24 volts provided by the Aimtec AC/DC converters power the display unit and the pump motor directly. 4 isolated DC/DC converters convert the 24 into 12, 5, and negative 12 volts. As the valves usually generate more electromagnetic noise, customers can use our AM10 TWM-YZ or AM20 EWM-NZ, all depending on the power that's required, dedicated to these valves to isolate the interference. The 5 volt levels, which is also provided by our AM10 TWM-YZ or AM20 series, powers the electrical control circuits and the communication module. To ensure the RS-232 signal quality, customers can use our AM1DM or AM2DM, which are 1 and 2 watt DC-DC converters respectively, to provide 6000 VDC isolation to power the signal line. The negative 12 volts provided by the AM2DM offers the necessary reference voltage to the OPA and DAC. Next, we have the transport ventilator. Since it's meant to be transported, this is much smaller than the previous ventilator. Since it's smaller, it only requires about 80 to 150 watts of power. In the block diagram, we see that the device is powered by an onboard medical grade AC/DC converter or an external 24 volt medical grade adapter. The 24 volts from the onboard AC/DC or external adapter powers the motor and the valve directly. To isolate the interference from the motor and valves, Aimtec's AM20 EWM-NZ DC-DC converter with 5000 VAC isolation is used to convert the 24 volts to 5 volts and provide power to the control circuits, sensors, and display unit. The AM1DM or 2DM-NZ are also used in this example to ensure the signal integrity to the RS-232 communication module. Now, for mechanical ventilators, which are actually the smallest size and therefore require even lower power. And again, Aimtec's medical grade DC-DC converters, the AM20 EWM with a 4:1 input voltage range, is built into the device to enable a flexible external DC power source. The input power is converted to 24 volts and powers the valve, blower, and system fan. Switching regulators, which are again non-isolated DC-DC converters, can be used to convert the 24 volts to 9 volts and 5 volts to power the sensors and the microcontroller units.